Okay, so we're going to do question 12.4 now. So in this question, we are given a Bertrand competition model with differentiated products. So we are given a demand curve, so from A and from B as followings, and we have the marginal cost for the firm being constant, given by CA and CB for firm A and firm B respectively. So question telling you that it can be shown that the best response function for firm A is this, and the best response function for firm B is this. Now question asking you to graph the two best response functions on the diagram, okay, and then find the equilibrium when assuming that CA equal to CB equal to 0. Okay, so on the diagram over here, I will have something like this. Alright, now on the vertical, I will have the price PB, and on the horizontal, I will have the price PA. Okay, so I'll be drawing the best response function for firm A first. So that is going to be PA equals 1 plus 2 PB plus 2 CA, everything divided by 4. Alright, as you can see from here, I got PB on the vertical axis and PA on the horizontal axis. So therefore, I would like to rearrange my function over here to make PB as a subject, because I have PB on the vertical. Okay, so if I rearrange this, I get 4PA equal to 1 plus 2 PB plus 2 CA. So therefore, 2B PB is going to be equal to 4 PA minus 1 minus 2 CA. Okay? And so therefore, PB is going to be equal to 2 PA and move the vertical, so it's going to be equal to -1, -2 CA, everything divided by 2, plus 2 PA. Okay, so therefore, as you can see now, I got PB as a subject, and it's just the vertical variable, and I got PA as a horizontal variable over here. Alright, so therefore, the number or the constant over here is going to be the vertical intercept. Okay, and the coefficient over here in front of PA is going to be the slope of the line. Alright, so now I do not know the values of CA, so I wouldn't be able to draw it precisely. However, I can guess a little bit. Okay, so I know this vertical intercept is a negative number because I got -1 minus 2CA, and given that CA is a cost per function, it should be positive, and so therefore the vertical intercept over here is a negative number. Okay, so I have a positive slope which is equal to 2, and I have a negative vertical intercept. So therefore I should be able to roughly draw the diagram for this. Okay, so I got a negative vertical intercept, so it will start somewhere from here. Okay, so it will start somewhere in the negative part. Now I do not know the value, so I'll just pick a random point. Okay, so I'll pick this is my starting vertical intercept. And the slope of 2, so it's going to be upward sloping. Okay, so I will just have something like this. Okay, remember the slope of 2, so I'll make it a little bit steep. Alright, so this is going to be my best response function for firm A. Now I do not care about a negative price, okay, since it's not economically meaningful, so therefore I'm just going to get rid of this part. Okay, okay, so I'll say I don't care about this bit. Alright, okay, so now I'm going to do for firm B. So it's going to be very similar best response function for firm B. PB is equal to 1 plus 2 PA, okay, plus 2 CB, everything divided by 4. Okay, now as you can see, I already have PB as a subject, so I do not need to rearrange anything, so that's pretty straightforward. Okay, so I would just have to separate them to get the slope and the vertical intercept. Okay, so in this case, as you can see, I got 1 plus 2 CB, everything divided by 4, plus half of PA. Okay, so therefore I know that this is going to be my vertical intercept. Okay, and this is going to be the slope, which is the coefficient in front of the horizontal variable PA. Okay, so therefore I know that I have a positive vertical intercept and a positive slope. However, the slope of this one is smaller than the slope of the best response function for firm A, so I know that this best response function should be flatter, okay, because having a smaller slope. And it's starting from a positive number because it has a vertical intercept, sorry, a positive vertical intercept. Alright, so therefore I would say I'll start from somewhere positive, which is say over here. Okay, I do not know the value, so I'll just pick a random point. And again, the slope is positive, so we have an upward sloping with a smaller slope than the best response function for firm A, so the line should be flatter. Okay, so therefore when you draw it, you make it flatter, and it's going to go like this. Okay, so I got my best response function for firm B, and therefore the intersection over here is going to be the Nash equilibrium, we know that. Okay, so intersection between the two best response function is going to be the Nash equilibrium. Alright, now question asking you to assume that CA equal to CB equal to 0 and find the Nash equilibrium algebraically. Okay, so we just have to find the values for the equilibrium in this case. Alright, so given that CA equal to CB equal to 0, okay, then the best response function for firm A and firm B will now become, so I got PA is now going to be 1 plus 2 PB plus 0, okay, which is 0, and divided by 4. So it's going to be equal to 1 on 4 plus half, okay, so 0.5 PB. So this is my first equation. Now the second best response function is PB equal to 1 plus 2 PA plus 2 CB, and in this case it's just going to be equal to 0 divided by 4, so therefore it is going to be equal to 1.4 plus 0.5 PA. Okay, and outside this is the second, the double star equation. So if I substitute the first star equation into the second, the double star equation, I'm going to get PB equal to 1 on 4 plus 0.5 PA. Okay, so maybe I'll leave it a half. Okay, so just to be consistent. Okay, leave it a half. Alright, so 1 on 4 plus a half of PA, and I know that PA is just equal to this from the one star equation. Okay, so I'll just substitute it here. So equal to 1 on 4 plus half of PB. So therefore, if I rearrange, so if I expand everything, I'm going to get 1 on 4 plus 1 on 8 plus 1 on 4 PB, and so therefore if I move this thing PB 1 on 4 PB to the left hand side, that will give me 3 on 4 PB equal to 1 on 4 plus 1 on 8, and that is going to give me 3 on 8. Yeah, and so therefore I know that PB is going to be equal to 1 on 2 equal to a half. Alright, so now I know the values of PB. I will just have to use the first. Okay, from the star equations, I know that PA is just going to be equal to a quarter plus a half of PB. And knowing that PB equal to a half, that is going to give me a quarter plus a quarter, and that is going to be equal to a half. Okay, so the equilibrium in this case is for firm A to be charging exactly the same price as firm B and equal to a half. Alright. Okay, so part B indicate on the graph how an increase in CB will shift the best response functions and change the equilibrium. Okay, so I'm going to just replicate the diagram that I got over here. Okay, and I'll move it to here. Okay, so I got PB, I got PA, and I have 0. Okay, so I know that my best response function for firm A is going to be here. Okay, and I know that the vertical intercept is just, sorry. Okay, so I'll start from somewhere over here on the negative side. Okay, and my best response function will just start from here. Okay, so I'll start from here. So this. And this is, I know that it's going to be equal to -1 plus, minus. So I'll just have to use the value for the intercept, -1, -2 CI divided by 2. Okay, so that's the vertical intercept over here. A bit clearer. So intercept over here, okay, is -1 minus 2 CI everything divided by 2. Okay, and for firm B, it's going to start from a positive number, and it's going like this. So this is the best response function for firm B, where the vertical intercept over here is having a value of 1 plus 2 CB divided by 4. Okay, so this is the vertical intercept. Now, the question asking you, if we have an increase in the cost for firm B, increase in CB, how's that going to shift the best response functions and change equilibrium? So this was our original equilibrium before. Okay. Now, if we have an increase in the values of CB, as you can see, nothing about best response function for firm A is going to be different because the vertical intercept is not going to be affected, and the slope will still be a constant number, which is equal to 2. Okay. So the change in CB will not affect the best response function for firm A. Okay, so best response function for firm A is not affected. Now the best response function for firm B, as you can see, the slope equal to a half, so it's not going to be affected by CB. Okay, so therefore the slope of the best response function is going to remain the same. So the slope is not affected because it's equal to a half, and that is going to be the same, doesn't matter what value CB is going to be. Okay. However, as you can see, the vertical intercept is going to be different because the higher the values of CB, the higher the values of the vertical intercept. Okay. But vertical intercept is going to be higher. Okay, so an increase in CB is going to push the best response function for firm B up, in a parallel manner. Okay, so it's going to increase the vertical intercept to a higher level. So I'll say this one will be 1 plus 2 CB dash, everything divided by 2, where CB dash is bigger than CB. Okay, so if we have an increase in the cos CB, it will increase the vertical intercept. However, keep the slope the same. So therefore, our best response function is going to be like this now. So this is the best response function for firm B dash. And therefore, the equilibrium is going to move to this point over here. Okay, so this is my new equilibrium at this point. So we are moving from this point to this point over here to the new equilibrium when we have a new best response function. Okay. So as you can see, the two firms are charging higher price now. Okay. So compared to the original equilibrium, firm B is going to charge a higher price, and therefore firm A is going to follow and charge a higher price as well. Okay. So the reason for that is because firm B is having a higher cost now, so therefore firm B will have to charge a higher price to cover the cost. Okay, and following the best response function for firm A, when firm B charging a higher price, then firm A is going to have a higher demand, and therefore firm A is going to be charging a higher price as well. And therefore we are moving along the best response function for firm A from this equilibrium to this equilibrium over here, where the two firms are ending up charging higher prices. Okay, so part C of the question asking you to indicate on the graph where analog to the Stucker-Birch equilibrium might be, with firm A choosing the price first and firm B choosing the price second. Okay. Okay, so we know that if firm A choosing the price first, firm A is going to be the one who taking into account the best response function of firm B. Okay, so firm A will be the one who, knowing that if I set a price, firm B is going to follow and choose his price following his best response function, and firm A is going to be taking that into account when firm A choosing its price. Okay, so therefore firm B is going to be the one who following. Okay, so he's going to use the best response function for firm B. Okay, so what we have is firm A will set the price first. Okay, and firm B will follow by setting its price on its best response function. Okay, so what we use now, what we use over here is going to be the best response function for firm B. Okay, and firm A is going to pick the price first. Firm B is going to follow by setting a price following his best response function. Okay, so now if I'm going back to my diagram over here, okay, so maybe I'll just draw another one to make it clear. Okay, so I'm just going back to the original case where there isn't any increase in CB or anything. Okay, so I got PB over here and I got PA over here. Now over here it's just my best response function for firm A, and over here is my best response function for firm B. Okay, so this is my original equilibrium, which is the Nash equilibrium in part A. Now if firm A can choose the price first in this part C, it is going to be the case that firm A is going to pick the price, and then firm B is going to follow on the best response function for firm B. So what we're going to have is we're going to have the price picked by firm A. So I'll just pick a random one. Okay. Now I do not know the exact value, so I'll just pick a random one. So PA going to choose this price, PA in the Stucker-Birch. Okay, and what firm B doing is firm B is going to follow this price, and set firm B's price follow on firm B's best response function. Okay, so what I have is I'm going to go up to the best response function for firm B, and therefore firm B is going to set the price on this best response function. Okay, and so therefore this is going to be the price set by firm B. In the Sakabash. Okay, so this is going to be our Nashi, our Sakabash equilibrium, and this is the equilibrium in part C. Okay, so what we care about is the best response function for firm B. We do not care about the best response function for firm A anymore, because firm A is the one who's setting the price first, and he is the first mover. So there's no best response function for firm A that we need to care about. Okay, so question asking you, is it better to be the first or the second mover when the firm choosing prices? Okay. Now, so as you can see, in the Carnot model equilibrium, it is better to be the first mover because you can charge, so you can set a higher quantity, and the other firm will just respond by lower his quantity, and therefore you're going to end up capturing a higher market, a higher share of the market, and earning a higher profit. Okay. Now in this case, when the firms are choosing prices, if you are the one who choosing price first, then the second mover or the follower can always undercut you a little bit and then capture higher shares of the market and earning more profit. Okay, so by being a second mover, they are going to have an advantage because they will know what price you're going to set, and they're going to respond to that by lowering the price a little bit, by undercutting you a little bit to capture a higher share of the market and earning a higher profit. Okay, so therefore I would say when firm choosing prices, okay, it is better to be a second mover. Okay, as the firm can observe what the first mover did. Okay, so what the first mover set, okay, for their price, and then lower the price a little bit. Okay, okay, so basically undercut a little bit. Okay, to get a higher share of the market. Okay, and therefore earn a higher profit. Okay, so it's better to be the first, so to be the second mover, because you will now be able to set your price lower than the first mover, and therefore undercut him, and therefore capture a higher share of the market and earn a higher profit. Okay.